Hey friends, welcome to TeKnowledGeek. I am Akshay and today we will discuss about cost-based optimization. So this is a special feature in the Spark SQL catalyst optimization technique where we have used the table stat and the filter selectivity and the join cardinality to capture the best execution plan for your Spark structured SQL query. So let's start today's session, but before starting let me ask you to subscribe the channel so you can never miss the upcoming videos and we can have more interaction, more communication. I can get your feedback and I can make more and more videos for you. So let's start today's session and please watch till the end because this is a very super complicated thing if you don't understand it properly. And so let's begin with the Spark Catalyst Optimizer. If you don't know about the Spark Catalyst Optimizer, you can check with the above video. And Spark Catalyst Optimizer, when it creates the logical plan and when it resolves the logical plan, it will create actually execution strategies, and there are several execution strategies, and there is a model to choose the best among them. So one is the rule-based approach, another is the cost-based approach. So first we need to talk about the rule-based approach and try to identify where is the problem. Rule-based approach, we have used the query structure to define the what is the build side, what is the probe side of any join, and try to broadcast. So if you want to use the broadcast as join, so that will decide which side will be broadcasted and which side will be not broadcasted and will be native to the executor nodes. So let's take an example, and you have two tables to join. One is table T1, it's having the 200 GB of data, and you have table T2 which has 20 GB of data, and these two tables are joined. And before joining, table T1 is actually filtered and only 100 megabytes of records is processed to the join. So if you only look at the table's size, then you choose the table T2 as your build side because it has the less size, and you just make the table T1 as the probe side because it's higher in size. But your decision is wrong because, like, if you choose the cost-based approach, you will only consider the number of records involved in join just before the join, not at the table size. So in that case, the 100 MB is less than the 20 GB of table T2. So in that case, there is a significant performance improvement if you choose the cost-based approach and take the table stat, join cardinality, and the filter selectivity as your decision, and to calculate the cost, and based on that you choose the best execution plan. So now let's talk about the various statistics, how they are collected when in a cost-based approach. The first thing is the table stat. So to gather the table stat, we can always have a command like analyze table name, compute statistics for the columns involved in the join. So in that case, you have both the average and maximum length of the columns, and you have the max size and mean size of the column, and you can have the distinct values and the null values of the column. So if the max and mean value of the column, if it is a numeric column obviously, and these are the statistics collected. And next thing is the filter selectivity. So in the filter selectivity, you have So you are checking a column value as compared to some constant. So if you just equal operator and the constant, if it is greater than the maximum value of the column or the minimum value of the column, then the selectivity will be 0. And if it is in between max and mean value of the column, then the total number of distinct value and inverse of it will be your selectivity. So inverse of the total number of distinct values in the column. And if it is a less than operator or greater than operator, let's say it's a less than operator, in that case, let's say is the constant value is less than the minimum value of the column. In that case, you have like 0 as the cardinality. Else, if it is greater than the minimum value of the column, then the constant minus mean value by maximum minus minimum value will be your column selectivity. So this is the way you can calculate the filter selectivity for any column. And if you use the logical operation to combine multiple filters, then in case of AND operator, like how you have chosen the filter selectivity of these two filters, they will be multiplied. And if the OR operator is used, then it will be the filter selectivity of the filter 1 plus the filter selectivity of the filter 2 minus filter selectivity of 1 multiplied by filter selectivity of filter 2. So that will be your filter selectivity after the logical operation. And if not operation, then 1 minus filter selectivity of your filter operation will be the final filter selectivity. The last part is the joint cardinality, where joint cardinality is calculated for the inner joint, left outer joint, right outer joint and the full outer joint. So first we will check about the inner joint. So let's consume there is a left side table A and there is a right side table B. So these two tables are joined using the column K. That means A dot K is equal to B dot K is the joining condition. Now let's now check how the cardinality is calculated. So for inner joint, so the cardinality is calculated as number of records, unique records in A just before the join operation into the number of unique records just before the join operation in table B. So let's check how the cardinality is calculated. So first we will take the number of unique records in table A just before the join operation and multiply with it with the number of number of unique records in table B just before the join operation, and then we will divide this whole number by the unique number, like distinct number in column K and in table A and table B, and take the maximum of them. So maximum of the unique record in column K in table A and compared to table B, and take the maximum record and then divide the number of unique record in table A into number of unique record in table B by that maximum number. So that will be the cardinality in the join operation in case of equijoin. Now for the left outer join, so that number is compared with the number of unique record in the A table before the join operation, and whatever is the maximum is taken as the join cardinality for the left outer join. The same case for the right outer join, it is compared to the table B number of unique record just before the join operation and take the maximum of them. So in case of full outer join, the cardinality calculated for the left outer join plus the cardinality calculated for the right outer join minus the cardinality calculated for the inner join will be the cardinality for this join operation. Now let's check how the optimal execution plan is calculated. So that is calculated based on the cost, and cost is derived based on the formula weight into cardinality plus 1 minus weight into size. So there are two components in the cost operation. One is the CPU cost, another is the IO cost. So here weight is just a tuning parameter and it can be configured and the default value is 0.7. Now to summarize the whole thing, we have discussed why the cost-based optimization is better than the rule-based optimization, and second point, what are the different stats taken care in case of cost-based optimization, like table stat. Table stat is just the number of distinct value or null value, or the average length and the max length of the column, and the max and mean value of the column if the column is a numeric data type. And then we check about how the filter selectivity is calculated, and in the third point we check about how the joint cardinality is calculated. In the last we check how the cost is calculated. It's weight into cardinality plus 1 minus weight into size, and based on that cost calculation the optimized execution plan is selected. Thanks for watching this video. Please subscribe this channel and please let me know your feedback through your comments and likes, and please let me know if you want to learn about some new topic in Spark. I will make sure I have created a video for you. Thank you so much for watching.